All right, the recording has started as well. Can one of you just unmute yourself, please, and let me know if you can hear me nice and clear?
Yes, Subha, we can hear you.
Wonderful. Sarbotam, good afternoon, and welcome to you as well. All right, folks. So, welcome to BayOne again. This is us, and some of you are probably on the bridge today as well. I thank you for your diligence and joining us for all these bootcamp sessions. So again, this is part of our Level Up program that we have been conducting online, and we invite a lot of guests. And today we have a special guest as well. And some of you might have met him already for the previous session. I have been conducting these Level Up programs both at BayOne and at client locations for many years now. And going forward, we will continue to do this. The idea behind the Bay 101 technical boot camps is to give all of you, irrespective of where you are in the IT domain, a good exposure to some of the technical areas like big data, IoT, cloud computing, DevOps, AI, and machine learning. But more importantly, to start off with the basics of programming in and around, front end, back end, and full stack technologies. So with that in mind, these are some of the things, again, that we plan to achieve over the next several quarters. It is a wish list, as I keep repeating. There are a lot of things here. And what we have done in the last 3 weeks now is cover some fundamentals on front end, particularly with JavaScript, HTML, and CSS. And the outline for these boot camps, as we have mentioned in the past as well, is twice a week. We conduct these on Tuesdays and Thursdays. These are 90-minute sessions, but often it runs a little bit beyond 5:30. It ends around 6 o'clock, but not any further than 6. So if you have to plan yourself, please block yourself 2 hours, 4 to 6, number one. And number two, because these are boot camps, we do not send out any meeting invites. So please mark your calendars. The Zoom link is typically sent the day before or the morning of the boot camp itself. And we also call out the topic. Now, the topics, as I mentioned on the previous slide, may be varied, and some of these may be of interest to you, and some of these may not be of interest to you. My suggestion, especially for people between jobs and looking to switch careers, is try to attend as many as you can, because it is going to be helpful, as you will realize from today's session as well. Okay, so why are we here? Again, I just want to reiterate this. As part of the interview preparation process, we strongly recommend that those of you planning for a job change have at least 100 hours of preparation, okay? 100 hours. And the reason we say that is across the board, there are several companies now offering professional interview preparation camps, and they recommend the same thing. They say 50 hours of classroom plus 50 hours of homework and exercise. And typically, if you are doing this full-time, it'll take you between 3 to 4 weeks. So plan for a month before you go for that job interview. And if you are already working somewhere, or if you can only devote part-time, so 3 to 4 hours a day, in that case, plan for about 2 months. And the reason they say that is the numbers are right there, the stats are there. It's not easy to get through, especially in the current scheme of things. Traditionally for us, the client acceptance ratio for pre-screened candidates is barely 9%, 8.4. And look at this number. The last 3 months, ever since COVID-19 has hit, the success rate has been less than 2%. It means for every 50 people that get interviewed, barely one person makes it, okay? So the key differentiator is going to be how well and adequately you are prepared. So in that endeavor, and continuing on with the theme of front-end technologies, building nice user interfaces, we have with us again our esteemed guest that we had, last couple of weeks ago, actually, Sarbotam Bandopadhyay. He's a senior software engineer at LinkedIn, and he spoke to you about the fundamentals and the timeline of how the entire front-end technology evolved over the last few decades. He's going to talk to us about a couple of challenging areas in the realm of JavaScript. Particularly, JavaScript, although is object-oriented, it is not quite the traditional class-based object-oriented language that you might expect having programmed in, say, Java or C++. There are certain things you can do in JavaScript. There are certain things you cannot. And there are certain things which are a little different. So you essentially have to kludge, or essentially have, know some tricks of how to implement certain object-oriented features using JavaScript. Okay, so Sarbotham today will be talking about some of those kludges, some of those workarounds, or some of those special features in JavaScript, including inheritance. And also, he'll be talking about passing functions as parameters, and a lot of interesting asynchronous JavaScript related stuff, which are known as callback patterns. And again, it's not easy, because there are, although this is a hot topic, people often run into problems trying to implement this. So he's going to tell us what are the things, what are the caveats to be careful about. And if you are indeed preparing for a client interview, what are the things that you should be really cognizant of when you prepare these topics? Okay, so with that in mind, I will pass the ball now over to our guest for today. Sarbotham, good afternoon. How are you?
Thank you, Suva, for the warm introduction. I'm good. How are you? From your voice, it looks like you're having a good time.
Absolutely, man. My job is to keep everybody awake on the call. So I have to sometimes literally shout. And sorry about that, but I'm definitely very excited, Sarbotham, because first of all, all of us here on the bridge, thank you for your time, because you have been very benevolent with your time. And in sharing some of these tips with all of us, particularly candidates who are preparing for interviews or who are looking to transition to front-end engineering careers. And the reason I say this, Sarbotham, is because there are certain things that they can read from books, but that there are certain things that they can only learn from experience, right? So unless they hear from an expert like yourself, sometimes they might be not very sure. Am I doing the right thing? They say that, for example, JavaScript is object-oriented, but hey, it does not support classes. And if it doesn't support classes, how do I implement some of the basic constructs of OOPS, right? So I believe you plan to talk about all these things today. So I'll just pass you the ball, and I've just made you the host as well. Over to you, Sarbotham.
Thank you once again, Suva. By no means I wanted to say that you're shouting, but I really like the energy which started the session. And that's kind of set a very positive note. But once again, thank you for the warm introduction and already setting up the tone for these presentations, what we are going to talk about. So thank you again. And thanks everyone for joining. I will start sharing my screen. So if you can see it and can give a confirmation, that would be very helpful.
Yes, we can see your screen, Sarbotham.
Great. Thank you. So let me start the presentation. So last week, we talked about front-end engineering in a very, very supersonic speed. It was from a very high level, maybe from 50,000 feet above. And you can find the slides when I share the today's slides version. If you haven't attended, you can go through them. And also there are recordings, so you can probably take a look at that. So from 50,000 feet, we'll come down to the ground today. Ground means literally ground. And we will talk about inheritance and asynchronous execution in JavaScript. So Suva has already given us a brief introduction why we need to care about it, and we'll drill down much further. So once again, my name is Sarbotham Bandopadhyay. I am a senior software engineer working at UI UX at LinkedIn. So talking about inheritance, I'm pretty sure you all know what inheritance is, but here a quick recap. For example, we have something, a very basic thing called shape, which might have a function called area. And from there, we can have many more shapes like a circle, a triangle, and a rectangle. They all have area associated with them. So instead of rewriting the area functionality in all of these shapes, we can write it in the shape. And sometimes maybe we have to override because the formula is not going to be the same. And then from rectangle, we can have another class, which is a special kind of rectangle, a square, whose length and breadth happen to be the same. So this is a very basic overview of what inheritance is. And I know you all know about it, but I just wanted to do a quick recap. So in JavaScript is not a traditional object-oriented language, or rather we say it's not a classical object-oriented language, Rather, it's a prototypal inheritance. So if you see other languages like Java, whenever you have to have an object, whenever you want to get an object, you have to instantiate it from a class. But in JavaScript, it is not always like that. You can create an object literally just by using object literal. Of course, you can have a constructor where you can use the new keyword to instantiate an object just like any other traditional object-oriented language. But in the new, when you are using it in the, it doesn't always have to be a class. Class recently came to JavaScript, which is a kind of a syntactical sugar, but we call these functions a special kind of functions as constructor. So as you can already see that there is a link called code, and we are going to have lots and lots of code. The slides are really, really minimum in today's presentation. So without any further ado, let's dive literally into the code and take it forward from here. So here are a couple of bookkeeping things or housekeeping things that you may want to do. If you want to follow along, I would suggest don't copy and paste the code. Just see and write it down by yourself, because that is one of the things which is going to help you a lot to understand the concept. If you just copy and paste, you'll probably go with the flow and you might forget. But if you literally want to copy and paste, you will have access to all these codes after the presentation. You can probably try there, and you can just watch the presentation and watch me typing and untyping. But if you really want to follow along, just type it. So you have a couple of options. If you have an editor installed and if you have Node.js, go ahead and get started with that. Or you can just go to this site called Repelit and click on Start Coding, which will take you to an online editor. Choose Node.js out here and it will take you to an online editor. I don't want to create another REPL out here, and you can keep typing out there. So if you see Repelit, the very first file which it will create for you is called index.js, and you can create many more files. So coming back to our topic, we wanted to talk about object literal and constructor. So object literal, one second, let me go back. So object literals are just like that. You can have anything. It doesn't always have to be const, but it is better if you're not modifying this object, just type it with const. It could have been let, or in the older JavaScript syntax, it could have been even var. So JavaScript is a loosely typed language. It doesn't have any type associated with it. So when you declare something with a var, const, and let, it could be anything: an object, a number, string, a symbol, anything. So in latest syntaxes, in latest specification of JavaScript, we have something called let and const. There is a difference, and we'll not be talking about those differences right now. We'll be talking about much more granular thing. So I created an object here called language whose name is JavaScript. And I could have added another property here, born on 1995. And as you can see, this is a string, so I have quoted it within a string. This is not a string, this is a number, so I have quoted it as without string. But in JavaScript, I can always change it. I can also make it as a string. And not only that, like, let me show you over here. I'll write some code on the REPL. So let's have a associated to 5. So a is now a number. I can also convert it into a string just by doing so. If you see this one, now a is a string. So these are some gotchas of JavaScript which are good and bad altogether, but we can talk about them in some later time. But this is an object which we have created. Now if we print this object, you can see how it will get printed, and we'll also print the language.constructor. This is really, really important for us. So in order to run this script, I'll uncomment rest of the code which I have written, and I'll just run this one. So in Node.js, if you want to import any file, you can just do a require in the CommonJS module syntaxes. And with the latest specification of JavaScript, you can also use import syntaxes, but we'll stick to require for the moment. So what is happening when I do require this script? It is not only importing this script, but it's also executing it and getting it ready to be consumed. So now when I click run, let me go back to the script once again. What I did, I had JavaScript out here and I had a property called born out here, and you can see these two things got printed. But now when I print the constructor, this is something weird, right? You probably wouldn't have expected from where did this object came from, why this function is associated with an object, why the constructor is object. So in JavaScript, every object at the very base level inherits from the object. And what do I mean by that? It might sound confusing. So let me show you a visualization, which I cannot show you on the REPL, but I'll use the Chrome DevTools. So I can open the Chrome DevTools either by right click. I probably won't be able to do it. Yes, I don't know where, I cannot find it, but I'll be using my keyboard shortcut and I'll open the DevTools. So let me copy and paste the same code which we had out here and paste it in the console. So now if I type language, let me increase the font. It might be too small to view. Now if I expand the language, you can see exactly the same thing which I was seeing over here. So there is a property called name and a property called born. Let me also prevent these warnings, which I don't want to show. Great. So here, the good thing about this dev tool is that it gives a little bit of more visualization. So I can now expand this object, which I would not be able to do it in this REPL. And you can see there is something new which you are seeing, which you did not see when it was collapsed. Only you see when it is expanded. And there you see something called proto. And you also see that this is an object. So let's expand this too. Now you see the constructor out here and you see the object. So these are the properties: has on property. This is actually a method. This is not a property. Has on property, is prototype of, and so forth. These all are available in the base object class. And that's how it also came to this object, which I instantiated via object literal. So if you need an object to be created, you can always create it like so. And this is recent version of JavaScript actually got a new data structure called map, which we earlier did not have it. So we used to use this as a key value pair, like in order to create a hash map or some kind of thing. This is a quick and dirty way to create a key value pair. And this is nothing but object literal. So I'll stop here. This was completely probably brand new. And feel free to unmute yourself or put something in the chat. Are you all with me so far? Did you get a hang of it, how you can create a object just by using object literal? No new keyword. You didn't have a class or a blueprint from where you could create an object, but just by typing an assignment.
Yeah, it's clear, Sarvatam.
That sounds great. So I think we'll move on to the next thing. Don't worry much about the constructor out here. We will see it in a bit. So let me hide my console again. And as you can see it, so we have, okay, something happened with the REPL. It is not showing to the fullest, but it's fine. We probably don't need to see the fullest. So with constructor, what we do, we create a function. We do not have a notion called, let's consider we do not have a notion called class, though with latest ES6 version, the ECMA script, we have a notion of class, but this is how we used to do it. So this is no different than a regular function. This is exactly the same function, but you might have noticed that I'm starting the name of this function with an uppercase letter. And this is nothing but a convention that whoever is reading your code would understand that, hey, this is a blueprint. This is not just a regular function. But other than that, it does not have any implications towards JavaScript as the language other than the convention. So what we do in the constructor, just like how would you do it in Java or any other language, you can accept some parameters and you could probably initialize it out here as the attributes. And you could also have a method which just says, say hello, and create a function. Then we'll see something interesting that I'm putting here in this class, which I have defined called rectangle. I have something called prototype, but let's, even before going to prototype, let's just play with this much. So once again, we'll go to the Chrome dev tool and we'll see how we can use this constructor. So when I've created this, now if I type rectangle out here, you will see that the same function got printed by the dev tools that, hey, this is a function, this is how its body looks like. So let's clear it up and create an instance of rectangle. This is the time when we'll be using the new keyword. So maybe I'll have rect. And as you saw that I did not even put let const or var in front of it, but let me put const out here. And we will see what is the difference of this let const and var. So I will create a new rectangle and I'm going a little bit slower. Let me know if the pace is too slow, we can speed it up a little bit. Because this is too much of code and not history, I thought a slower pace would be useful. So if I print the rectangle out here, I did not even print it. I'm just typing it and Chrome DevTools is auto-completing it. So if I print this rectangle, as you can see that it has a length called 3. That's what I have passed. The width called 4. And the say hello function, which you has expected from here, got created. Again, we have a proto. If you expand it, now this time, if you remember from the last time, I have not changed it out here. The constructor was an object, but this time the constructor is a rectangle. You can even expand it. As you can see that there is another proto. Now, if you expand it, ultimately you go to the object. So you can see that prototype chain is getting established. So we have these functions, say hello, and now I can call this function rect.say hello, and you'll see that it is returning hello to me. Now let's see a new syntax out here. I have added something called rectangle.prototype.area. So you probably might be thinking, hey, where did this prototype come from? When you expanded this rectangle class, when you just printed this function rectangle, we don't see anything. It's just a function body. So where did this prototype come from? Come to this rectangle. So this prototype, if you convert this into an object, you will see that this rectangle has a prototype with it, and we will be assigning a method called getArea, and you will see it right now when we'll recreate another object from here. So let's just copy this code. Rectangle is already out there. We'll clear it out again and we'll paste this. So all we are doing with this code, we are telling, hey, prototype, add a method called getArea, and when this getArea method is getting invoked, whatever you have associated to the length and the width, multiply them and return it to me. So now let's create another object, new rectangle, but I'll be using the word const, and I'll just use the same rect function out here, and let's see what happens. So let's have this one. So as you can see that uncaught syntax error, identifier rect has already been declared. So I cannot redeclare it. But notice the fun thing out here. If I just remove the const keyword, though you might think it is as a constant that I might not be able to change it. Let's see what happens out here. It will tell me that, hey, assignment to a constant variable is not possible. But what I can do, I can change this length to anything. So that's, don't consider it like finally in Java that you won't be able to change anything. We have a notion called object.freeze. With that, so we are not trying to go much off track, but a little bit. If I use object.freeze, and if I use this rect, now you will see if I do rect.width, maybe something, maybe 20, and if I print rect, I did set the rect.width to 20, but when I'm printing the rect again, you still see the width as 4, so that will not change. So that's how you can probably create a constant or finally. But coming back to our notion of creating a new rectangle, so let's create const. Let's go back to rectangle for a second because I wanted to show you something. If you remember, previously I just added this thing to the prototype. I just added rectangle.prototype.getArea to the actual rectangle. So now let's revisit our previous rectangle which was created. I'll create another one also and expand it. So as you would expect like there was a length, there was a say hello, and there was a width. Let's expand this prototype once again. Now you see something called get area, but this object was already created. How did this get area come over here when we previously saw the instance? We did not see any get area. It is because whenever you add anything to the prototype, no matter how many object has already been created or how many objects will be created, each and every one will inherit from there. But this is not true for the instance method, because whenever you will be changing the instance method out here, like if I had changed the version of rectangle out here, the previous, if I would add another method out here, this rectangle would not inherit it. But no matter how many times or how many things I add it to the prototype, the old and the new, they all will get it. So let's create a new rectangle, and I will not close this. Let's create a new rectangle. Const. And maybe this time we'll pass 5 and 6. Oh, I should have. See, my mistake. JavaScript is smart to tell me that I'm making a mistake. So let's do new rectangle. So we know that the new rectangle has get property, get area method. Now we'll add another method. We'll add a new method called toString, so that whenever we call toString, right now also you can call toString. You should have one thing called toString out here, a function which is already available in the object. So even before overriding it, let's see what the existing toString does. So if you see, this toString is just telling object, nothing else, which is not very useful to us. So let's override this, because we know this is a rectangle and it should always print it's a rectangle. So now let's add it. Let's expand our old rectangle, expand the proto. Now we have a get area and we have a toString on this proto, which we'll also have another toString out here, which is on the object. But this is what we recently added. So let's see this guy a little bit. So this will have its own prototype and it will go on. So this is the chain which will go on. What about our new rectangle? So we definitely should also have the toString out here, because we already talked about it, that if you add anything to the prototype, it will be available to all the new objects as well as the old object which was created. So say hello once again, it's an instance method. That's why you see it over here. If you expand it, you get to see get area and toString. And this is the fundamental of prototypal inheritance. Are you with me so far? If this part is clear, then the inheritance chain will be much, much smoother to understand. I will consider the silence as a yes. So, and we will move on. So we understood how to create objects using an object literal. We also saw how to create a constructor or a blueprint and how to create objects from this blueprint. We also saw what does prototype mean and how is the prototype chain is established in JavaScript object structure. So now that we understand the prototype chain, let us establish the inheritance. We will be using the rectangle as our base class in all the examples, and we will be inheriting to another class called square, which is a special kind of rectangle in which the length and the breadth is just the same. So if you see the code, nothing much is different. We already saw it. We have a rectangle which has a length and width. We also associated the get area function to the prototype. We also have a toString function, just like the previous example. But the things will start changing now onwards. Now we have a function called square, and the way we are inheriting what we are doing. But let me pause for a second. Even before talking about this, let me talk a little bit about the this. So that will be much clear. So suppose we have a function. Let's take a very basic example called foo. Let's make it lowercase and see if it works. So if this is foo, all I'll be doing, I will be setting this dot name to name, whatever name being passed. And let's pass a name out here. Now see what happens. So I have this function foo. So let me call this, let me create a variable called if, and let me invoke this function foo without passing the new parameter, without using the new keywords. So the name is if. If you are expecting that the if will be instantiated, that won't happen. So this function will just be executed as any standard function. But even before calling this thing, let's call this dot name. We don't have anything out here in this scope, but the moment you call this function, what is happening? This function is setting this dot name, and this belongs to the global scope because I have not used the keyword new. So we'll see it just now. So let's run this function and let's print this dot name again. Now you see the if this is belonging to the global scope. Now let's create another function. Let's invoke this function once again, and this time we will be actually instantiating it. So let's use b for bar. We'll call foo again, and we will pass this time the name as b, and we'll ensure that this time we'll pass the keyword new. This time if I print, let me print if also. So what has happened? Nothing has happened in the if. It is still undefined because this function did not return any value. If I do not have any return statement in any function, it returns undefined. So let's print b, and this time we see that the b is an instance of foo and it has a name associated with it. So if I print this dot name again, nothing has impacted this dot name because this was scoped. So this dot name is still foo. But if I call the function foo again with just like so, b, let's not even assign it to b, you will see this dot name has changed to b. So what is happening? So let's clear this thing again and let's write this function for the time being. We already have this function. So what exactly is happening when I'm using the keyword new and when I'm not using the keyword new? So when you are not using this keyword new, it is just executing as a normal function. The foo gets executed, you pass a name, it takes the name and assigns to this. So this right now is pointing to the global this, which is the window object. So you can also do window dot name and you will see it is still printing b. When I use the keyword new, JavaScript interprets this function as something like this. So it probably creates a new object in its local scope, and then it is assigning this dot name to whatever we passed, and then it is returning this. And you could have named it any than this. This is how it is happening when you pass the keyword new. If you do not pass the keyword new, it's just executing like any normal function. This is treated as whatever is the scope. I use the word global scope, but let me be very specific. It is the scope of the parent, whatever the current execution context. So current execution context here, it was the global scope. That's why it took this, but it could have been wrapped in another functions also. Let's not deviate from our topic. I just wanted to share what is the difference between using new and not new, but we'll talk about this and all in a much granular details. So now when I'm creating this base class square, I'm calling this rectangle with a keyword, and you can see this one, I'm not invoking it directly. I'm using a keyword called call. And the reason we use this this way, like call, we also have a mechanism called apply. In both the ways, we have the opportunity to override the current context. So when square will be called with a new parameter, that this will be pointing to square's instance, and we are passing the same thing to this rectangle function, telling, hey, when you are assigning to this, don't create a this. I am passing you the this. Use this, and assign all this length and width, whatever I'm passing, to this new this, not to your this. So far, so good. Then we override the method because it's a square. So we of course want to override the method toString that, hey, this is a square. We don't want to print this is a rectangle. And then we create a square. So let's run this function. Let me comment out this part and run this function. So it is taking a little bit of time. Let me go to the index and comment out this two part, comment out all of them because we are only looking at 2.1, and let's run this. So now if you see the code out here, I think it is too big. Let me just minimize a little bit so that we can see side by side. If you see the code, all we are doing, we printed the console log, we did the square.length, which was nice, 3. We did square.width, which was 3. But when we did square.getArea, it is telling getArea is not a function. But what we have seen so far, that if you add anything to the prototype, it should be available to all the instances which are getting created on that particular constructor function. Either they have been created before or after. So what's so special going on with this square when we are inheriting it from rectangle? So what is happening? We have not updated square's prototype to rectangle. So though this length and width is getting set, this prototype functions like the getArea and getToString was not getting inherited. So we need to set the prototype of the square to an instance of a rectangle. So we are telling, hey, set your prototype to this thing. We saw that, right? When we were expanding the __ proto, that it was pointing to another thing. And that's how we need to tell the JavaScript, hey, do this thing. Now let's run the function once again. Now you can see that we have a getArea. Now getArea is working properly. Oh, maybe I have too many other things. Let me comment out this part too. Let's rerun so that we have less clutter. So now getArea is working properly. Now if I do, the square is an instance of square, which is true, but square is an instance of rectangle too. So that's pretty interesting. Now this is instance of two things. It's instance of a rectangle. It is instance of a square too. So if you have worked in Java, you probably know about reflections, right? You got an object, you can probably look up what its class was, and you could probably recreate another object from there. In JavaScript also, we could do similar things. So I can have another square, and I could use the new operator and on the squares constructor and probably pass a different length out here. So after I do this, let me run another square to string and another square's value and another square's getArea. So let me run this. So we'll be printing, we hope this will return as a square. We also hope that when we do square to string, of course, this will return a square. And when we'll return, when we'll print a new square constructor to string, it should print. Let me change this thing. We're rushing too much. Let's not even go there. Let's just do this much. So let's run this. So if you see, for the square, it was an instance of square as well as rectangle. Of course, like if we have an animal class and we inherited from there and tiger, so tiger is of course an animal, and tiger is also a tiger. And if we clone a tiger, even that should happen, like tiger should be a tiger and tiger should be an animal. So we cloned this one. So another square to string, it is a rectangle, but my square is still pointing to a square. So what has happened out here? Something else we are missing. The thing which we are missing is that whenever I'm establishing a inheritance in JavaScript prior to ES5, these are the two things which I have to do mandatory. Like if you really want to take a note, you make a note of these 2 points. So in your base class, you set the prototype to a new instance of the parent class, and you also set the constructor on the prototype to the base instance so that you always have it. So 2 points, if you really want to take a note about it, is these 2 things. So let me comment out this part so that the top part will still form an error. And last part, if we do it, like I'm cloning it again, whatever I have done here, the new constructor, I'm writing the same step out here and I'm doing a toString. So this time it should print it is a square. So now if you see, my another square is still printing it is a rectangle, but since I have updated the square's prototype to constructor, it is printing a square now. So this is how we have established our prototype chain or perfect prototype chain. But you don't have to do this today. Why did I show it? Because this is the perfect example to understand how the prototype chain is getting established. But you still don't have to do it. Today we have much more syntactical sugar. But prior moving to the syntactical sugar, let's see one new method which got added to the object in JavaScript version 5, the ES5. So if you see what I was suggesting here, that we need to set the prototype of the square to an instance, I missed a article, to an instance of rectangle. Otherwise, the methods of rectangle will not be available to the square. So we have a new method called object.create. And what does object.create does? The object.create methods creates a new object using an existing object as the prototype of the newly created object. So I could have just used an instance of a rectangle to create a square without going through so many things. So in this example, let me uncomment the other part so that we will be only running this example. So if I go back to my object.create, I have something called a language, which is JavaScript. I am creating another language with respect to JavaScript. And if I print both of them, you will see the another language already has the same name called JavaScript. And if I explicitly print out here, if I print another language, you will see that there is no property called name. But if I print another language.name, you will see it is printing JavaScript just because of the prototype chain. So let's run this. I think it should clean it up automatically, but let me clean it and run this. So if you see, when I am printing another language, you don't see any property. It does not have anything because I have not associated any property. I could have given here something like this, maybe year. Let's use a number, 1995. Now, if I run this example again, you will see what happened. Property description must be an object. Interesting. Okay, let's not get into this thing. We will take a look at it in a bit. We have a much better example. I don't want to debug in the live demo. So let's look at how we can use this object.create and create a prototype chain. So this is what we are doing. We have the same rectangle. We'll not go through this rectangle code anymore. We have the square, which I am calling the rectangle. And instead of, these are the 2 keywords which I suggested earlier, that if you really want to take a note of the 2 things, this is what you want to make a note, that the base class's prototype is set to an instance of parents class instance, to an instance of parent class, and base class's prototype.constructor will be set to the base class itself. So we are not writing this code anymore. This is sometimes gets confusing, and that's why JavaScript came up with much more prettier syntax, even prettier than this. So all we are doing, the same thing. Let me copy and paste both the things. We'll put them side by side so we exactly know what we are doing. All I had here, I was assigning it to a new instance of rectangle. So I'm taking this prototype, I'm taking rectangle's prototype, because we know that object.create will be assigning it to the prototype. And then I'm passing a constructor function, which was this statement. So this is ES5 syntax. Again, you probably don't have to make a note of it, But if we run this whole example, I have another square which is getting built with the same thing, same mechanism. And you can see how it runs. There will be no difference than the previous example. So let me go back and run this one. So now we see that our square is an instance of square as well as rectangle. Another square is also a square, and then another square which was created, which was cloned from a square, is now also a square. And square.toString is, of course, it was a square. So this statement is synonymous to this statement. So this is how we used to do it in pre-ECMAScript 6 version. With ECMAScript 6, things became much more simple. Like it is really, really obvious if you see it. We got a new keyword called class. And just like how you have in modern other object-oriented language, you have a constructor function, then you just specify your functions out here. It could be any functions. And when you have to have a child class, all you need to do is to use the keyword called extends. You extends from the parent class. You have its own constructor. And this is the only keyword that you need to know is called super. So you have to, instead of going through rectangle function.call and passing the instance of this out there and overriding, if you have remembered, which we are doing out here, when I was calling the rectangle, overriding the this and passing the parameters, you don't have to do anything. You can just call the super and pass the desired arguments, and you are done. This is all we need to do for inheriting in latest JavaScript. But you still need to understand the prototypal chain, because this is a syntactical sugar. In the underlying thing, nothing has changed. We still have the same notion of prototype chain. So let's run this once, and then we'll see it also in the JavaScript console. So let's run this. We should not see any difference than what we are seeing right now. So we still have a square, we still have another square, everything is working properly. But let's visualize this change in our browser's console. So all I have done, I have copy pasted the blueprint of rectangle, I have copy pasted the blueprint of square, and now I'm creating an instance of square. And now we will expand the squares instance. So as you can see, we still have a proto associated out here. These are the two properties which was associated with the instance which we created. And if I expand it, the constructor is square out here. If I keep on expanding it, then we go to actually rectangle. So if I expand it, now this is going back to class rectangle. So underlying inheritance is still built up in the prototype chain. And that's why I personally feel you still need to understand how it was done in the pre-ES5 era, when the ECMAScript 3 version was there, so that you can always get the concept of how this whole thing was done. So moving on to the next, what we have. We already talked about this one, the prototype, why it is important. We'll talk about it once more. So we will talk about prototype once again. So all I was trying to suggest, like you can have a rectangle, you have already extended it, everything is done. Now, even after this square is instantiated, even after I have created another square, I can add a method, say hello, to the rectangle's prototype, and the say hello will be available to already created square and already created another square. So we already talked about this, so I will just run this example and not spend much more time. So let's run this. And we can see, yeah, say hello function is already available. And this is the beauty of prototype. You can keep on changing it. You can keep on changing it. Of course, you should not probably change it, but you can amend it. And this is really, really helpful. What are the other ways that we can create objects and we can have some sorts of other inheritance? So there are two things. one is called object.assign and one is called object.spread. So as the name suggests, object.assign, it will just assign that the source object onto the target. So let's see this example. We are probably dealing with a lot of languages today. So by now, this syntax should be familiar to you, that object literal. You can literally have an identifier, starts with a curly braces, and you can have a property and a value. So if I have to print this right now, you will see language. So if I create yet another language out here, I can use this method, which is a static method. You don't have to instantiate an object. This is just like a static method which is available on the class. You can use this assign method. This is my target object and this is my source object. So if I run yet another language, we'll run it in a bit, I should see that this also has a name and JavaScript. Now let's create another, let's run this, then we'll create another language. So if we run this, as we expected, language and yet another language, which is a kind of a copy, they both have the same thing. But it doesn't end out there. I can also change it. So what happens when any guesses what will happen when I do this? One more language, when I'm using the language and passing this override called name is Java, which was also released in 1995. So if I have to print one more language, I have kept it commented purposely. So if I run this, as you can see, as you expected, one more language, the name is Java and the year is 1995. But I'm not sure if you already expected this, the language also got mutated. So even my language, which was supposed to be, which was JavaScript initially, it also got mutated to Java and it also got a new property year. So it is helpful sometimes, but if you are just using it for the sake of object cloning and object copying, this is not the safest method because it can mutate your target object unintentionally. So we have another syntax called object.spread, and the spread syntax is like this. You just spread it like 3 dots before any objects, which will spread it, the object. Like spread, I would think it in such a way, like if you have a deck of cards and you are just spreading it on the table, like all 52 cards are spread on the table, one after the other, it is something like that. So you're just opening up the language. So we still have JavaScript. If we print it, we will see the language's name is JavaScript. What we are doing with yet another language, we are spreading an empty object, nothing is there, and we are also spreading the language. So let's not go into the one more language again because we will see some changes. So this time we will run object spread example. And it's working as desired, like language and yet another language, both are having exactly the same thing. And now if we have one more language, this is the beauty of spread. My original object, that is the language, which will still retain its originality, it will not get mutated. And my one more language will be built on top of that with newer values. So this is what is spread is doing. Now, any guesses how our prototypal chain is getting established? Without any suspenses, let's see. Let's see what it is doing. So let's copy and paste this whole thing, and let's expand. It's already there. It has done for us. So if we see, this is getting it from object. Why? Because we were because the actual language is still inheriting from the object, and what we did not copy anything from there other than its values. So if we expand all of them, this language initially was originating it from the object, and that's why everything originated from object, because we are not copying anything when we are spreading. But once again, just to remind you, we were copying the prototype when we are using the create. So these are the few ways you can establish inheritance in JavaScript, and these are the way you can set it up. But why do we need to really know about inheritance? how often are you going to do these things, base class, child class, by hand? Shouldn't the library be taking care of all these things? Yes, library will be taking care of all these things. You hardly will be doing it in your day-to-day activities. But if you have to do something, some changes across the application, and maybe it's a huge application and you want to add a new method to it, if you know about prototypal inheritance, you could probably add it to the very base objects prototype, and that will be magically available to all the objects which are getting created. So a couple of years back, when I think in ES5, though we had the ability to override the this, but it was kind of a tedious, right? You have to call that function, then with a call syntax and so on and so forth, and you have to remember everything. So somebody came up with a concept called bind. And what bind would do, it will create a new copy of that function. Whenever you will invoke a function with the bind keyword, whenever you will not invoke a function, whenever you will be invoke a function, and prior to that you have already bounded it, you could always override the this. So this is an excellent excellent example. If you go to John Resick, he is the creator of jQuery, by the way. So he has an excellent article, not an article, it's like a tutorial out here. And this is the slide number 86. So he will keep on building it up till here. And if you can see it from here, all he is doing, he's assigning this bind to prototype. So if you don't understand or have the notion of prototype, how it is actually playing it in JavaScript, you will never be able to do it. So by doing so, if you do these things, in today's world, we have bind available to the functions. So by doing that, suppose if I have function foo, something like that. So I'll be having foo dot. By now this is there in the language. I didn't have to do it, but instead of this bind, it could have been anything. Maybe you have some of your homegrown method, like maybe in your application you want all the functions to have some kind of serialized method. Maybe toString is not sufficient and you don't like the name toString. Maybe you want to add serialize and deserialize method to all the functions or something like that. Some use cases, bind is a very, very good use case. You need to know about prototype chain. Or maybe you have a base object, and depending on certain criteria, you want to augment that object with a new property. Like if you're dealing with an app which has different kind of role, you could probably augment it, and so on and so forth. So this is very, very important concept of JavaScript. And it doesn't just end out here. This used to be an interview question, like, can you implement bind, or can you implement this this function on the function? So one more thing I would like to show you out here. I'm sure John has taken care of that thing. Okay, I don't see it out here. Maybe in the later slides it will be there. When you are adding something to the prototype, you just don't blindly add it. You should do a check whether that function already exists or not, because otherwise you might be overriding a function which already has been defined. So you must be doing that in some later slides. I am not seeing it out here. So in this function, you will actually check whether the function.prototype bind exists. If it exists, you don't do anything. If it doesn't exist, you write your custom logic and take it forward. So that was JavaScript inheritance. I know it was way too much. We talked about a lot of things, but if you really have to remember few things, remember that it is always prototype. That's how the inheritance is getting established. It is the base classes prototype needs to be assigned to the parents. Child classes prototype needs to be assigned to the base classes instance, and also child classes prototype and the constructor should point to the child class. Otherwise, all the cloned object from the child object will refer will be an instance of the parent class and not the child class. So next topic is, by the way, all the code examples that I talked about will be available in this link. which I was just showing you. So you can take a look at them. After the session, I'll be sharing the PDF version of the slides, and you should have all the links. And here are a few resources. I already talked about this book last week in the last session, the JavaScript, the good parts. If you want to understand whatever we have been talking so far in much more detail, or if you want to refer back, refer the chapter 3 objects and chapter 5 inheritance, and you should have a better understanding. If you are still missing something, this is a really good book and very concise. Next, we'll go to asynchronous execution, but I would like to take a pause before we jump. If we have anything to discuss, let's discuss, and I'll also probably take a sip of water and we can continue. Do you have any questions? Silence is not always nice. You should have some questions.
So I have a couple of questions. This is Suva Sarbotam. Why don't you take your water break? When you come back, I'll ask my questions.
Suva, go ahead. I'm here. I have the water here. Please go ahead.
Okay. So I think just for the benefit of the audience today, right? Because we have some people who are not very, who haven't had a lot of programming done. So you might want to just repeat once the spread versus the assign thing. It almost, for those of us who come from a procedural language programming background, it's almost like passing a variable by value and by reference, right? In one case, it alters the hierarchical structure in that it's overriding the values, as you saw in the example. But using spread, of course, we were able to avoid that. So if you can just sort of revise that for the benefit of our audience, number one. And number two, you did touch upon bind and, the notes from John. If you could give, our audience an example of potentially why they would want to use prototypal bind, like a use case from a functional perspective when doing programming.
I think those are great things. So let me address the object.assign and the spread operator. So by the way, spread is very new. It is brand new in the latest JavaScript. If you are running, probably if you're in Node.js even prior to maybe 10, I'm not sure if you have spread operator out there. So let's talk about them, and then we'll come to an actual use case why you would really want to use bind and what are the use case of bind. So object.assign, when you're doing it, the notion is telling that you are mutating the existing object and also returning a copy. So this is not just, it is not just mutating the object. So maybe the intent was that, hey, assign this, whatever I have, the target thing. These are two separate things, but sometimes I have seen in my experience that people try to use the object.spread and object.assign interchangeably, but it is not the case. You don't want to mix them. It is like comparing apples and oranges. The basic purpose of object.assign is to mutate the target object with a source object and override it if there is anything. If there is nothing to override, augment it with the past attribute, and then also return it back, return a copy if you want to use it. It is just like that. But when we are using the spread operator is completely a different league. It's telling, I don't care what you're doing. You want this, I'll just give it to you. It is like, suppose you have 2 deck of cards and the spread operator, suppose you want to shuffle 2 cards. So the spread operator is something like that. Hey, okay, here are 2 decks of cards. I just put them together, create a copy of them, I just maybe photocopy them. I got a cards, 52 cards and 52 cards. I have just photocopied them, put them together and give it to you. So this is object.spread. It is just like that, nothing else. It doesn't caches anything, it doesn't impact anything. But the main benefit is immutability. When you're dealing with JavaScript, it is a loosely typed language. And if you happen to change your state a lot, if you happen to actually mutate the current objects, it might impact in some memory, some storage leak, some state leak, and it can impact your application state. So if you use, you probably have heard about this library called Redux if you are in the React world. So React, even before Redux was there, the React world and Facebook team came up with a a library called immutable.js, which would facilitate all these things. It will not allow you to mutate an object. If you created an object via immutable.js, if you want to do an object.assign, it will throw an error. You can never do that. But it has been observed that we want some sorts of immutability in the JavaScript and create copy of objects. And that's how this object.spread operator came into the picture. It was proposed, I don't remember exactly at the top of my head who proposed it, but in JavaScript, even you can propose something. You can propose it. It has to go through the committee. And if people like it, it will go through the committee. It will go through different stages, and then it will become mainstream. And again, just to summarize, the main purpose of object.spread was immutability. You get anything out here, you just copy them, not a shallow copy. It's a deep copy out there. It is not pointing to those objects. Let me take a moment out here and show you what is shallow copy and what is deep copy in JavaScript. Things will become maybe much more evident. So let's consider I have an object here called, I think I was having something. Okay, let me copy this object. This is nice. I already have it. So I have an object called A, which is having an attribute B, which is 2, and C, maybe let's make it 3, which is nice. So now let's assign another object called B, and B will now be A. So what is happening out here, B and A, you might think they're two different copies, but they're actually not. B and A both are pointing to the same memory location. So guess what happens when I change B.C to 4, it not only changes B, but it also changes A. So this is the what you're talking about, Subha, the reference versus the actual value. So this doesn't happen when you do with object.spread, but don't just consider reference when you're talking about object.assign, because the whole purpose of that is to mutate the current object and return you a copy of that, return you a copy which got created from there. If I go back again in this object.assign, so this guy got, when I pass this language and I'm passing this new key value pair object, it is mutating the language, but when it is returning me, that object is no longer pointing to this one. So that's a deep copy which is happening. After mutating, it is returning me a deep copy. Is that clear before moving on to the prototype thing?
Yeah, so
I'm good from my side. I'm sorry, there was a question from the audience, please.
No, it's clear actually. It sounds something like a reference type versus objects are reference type in JavaScript, right? So I think once in the heap under the hood on the heap, I think variables might be stored at one place, and if we change the instance, I think automatically even the original parent will also change. That's correct, right?
Right. That's correct. So moving on to this bind thing, bind is very, very important. So let's see one example again. Maybe we'll have too many examples. Let's see this one. So suppose I have a function once again here, and maybe this is an utility function, or maybe this is a function like it's a callback function in the React world. Like when let me take a better example. I think that will be much more clear. Let me take a better example. So it's time for live coding. I think everything should work fine, hopefully. So suppose I have a button called, and maybe I have an object here. Now, what if I want to, this is going to be a very simple example. What if I want to change the value of greet to high when this button is getting clicked? So I could do something like that. Let's get a handle of this button. So I'll get const button. So you get a handle of this button, and why is it showing me error? Oh, JavaScript, you cannot have this semicolon. It could be a comma. So button dot add. Maybe you're seeing a little glimpse of asynchronous programming out here. So I'll be assigning a click handler to this one. And I have a function out here. A function. Let's not write anything out here other than console.log this. Let's have this function out here. Again, it is showing me some error. Why? Okay, no error out here. So let me also open up the console, clear it up. So the whole intent out here, we want to change obj.greet to high. There is a typo. So now if I click this, you see that this is pointing to this button. No matter whatever it is, wherever I attach this event listener, it will be that thing. So if I had something else out here, it will be this. So with this, I can no longer update this object. But what I can do here, this is where the bind will come very handy. I can bind and pass this object out here. Now if I run this, you get this object. So what I could do, stay here. What I could do here, now this is the usefulness. This might look very silly why we are just using bind and all when I have access to the object directly out here and I can mute it out here. This is just a basic example. It could have been a method which is on that object which I want to call, which might do something else, and that can have nested cascading effect. So we can do this dot greet to high, and I can have and if we want to log it, we can do log this. So high is not reference because this is a string, and JavaScript was thinking it as a value, some reference. So now we see the object got changed to high when we are doing this console log. So this is how it is happening. So it's mostly happens primarily with the event listener. So if you happen to have a, let me see if I can pull up some components. I would prefer to go to the React documentation. I have it out here. So you create a React class. Let me expand it a little more, increase the font. So you are creating a class like here, you are rendering hello world and so on and so forth. But you will also be having much more functions out here because that's how the interactivity will come. So let's see if they have any such examples out here, and which will be much more clear. So this is how, which is happening. These are ES6, by the way, ES6 syntaxes. So going up again, you see that this is using the keyword extends. And now if you see, this is where it is happening. So all you want to do when the handle click is going to happen, that this will point to the the instance wherever it has been clicked, the node wherever the click event has happened, or wherever the click event was targeted. So this will not have access, this will not have access to this state. So what you want to do, that's where you want to do this bind operation. Like whatever is happening in the handle click, it will probably be able to call this dot set state. So we should, so this is what is happening. If you do not pass this bind out here, this, when the handle click will get executed, this will be pointing to that document node, and if you would like to call this dot set state, it will throw an error. So this is where you would like to use bind, and this is one of the best example of bind. And this is not only just React world, it's true probably in any modern JavaScript components wherever you are writing. Is that clear now?
This is great. Thank you, Sarbotham.
No worries. No worries. The whole intent of this session has to be like, please feel free to ask question as many as you want. Like this, the whole intent of this exercise is like this concept, these rudimentary concepts. I don't know if they really talk about it, but most of these things are self-taught, and you have to go and dig through materials and learn it. Sometimes, like when I was learning the callback pattern, which we'll be talking in a moment, I did not understand it. It really took a long time for me to comprehend what exactly was happening. But probably if you see someone doing it, you see it from the different angle and you get to see it. And so you probably get a better understanding. So please feel free to ask any questions if you have. I will try to answer them to the best of my knowledge. And if I cannot answer, I'll make a note about it and I'll get back to you over the email or maybe some other way.
So I have a question.
Sure.
So I mean, the bind method is the fat arrow function an alternative for that? So the latest ES6 fat arrow functions?
No, that's a good question. No. It is not exactly. Fat arrow has a different, sometimes we call fat arrow, but most of the time you call it arrow function. Arrow function is completely different. So it is the biggest difference between arrow function and the normal function is the lexical this. So lexical this is whatever is the current context, how it was called, so it will always go there. But even if you generally use fat arrow functions, which is an anonymous function, in a callback pattern. You generally don't have a fat arrow function directly assigned to a property. Even if you do that, you will probably assign it to a variable. So that's also kind of a named. So let me take a pause. Let me since you brought up this topic. So there are two ways how you define functions in JavaScript. One is function declaration, one is function expression. So if you are doing a function declaration, which you just do with function name and then parentheses, that's a function declaration. Or you could also do like var foo, const foo, or let foo equals function and then parentheses and then start it. So why not I write it down, because it will be easier to visualize what I'm talking. So there are two ways you can do it. You probably have seen me writing functions like this. So this is one way which you can write. The other way you can write foo equals function. So I'll not go into the exact detail right now, because there is a primary difference between these two things are hoisting. So that's a different concept which we'll talk about. There is a hoisting out here. But even if you see both these functions, you can always call them. I should not have used foo in both the cases. It should have been two different. But either way, you could always refer them just with this name. So what happens with this arrow function? Arrow function is kind of a not a replacement, but a kind of replacement. So if I have a function like this, arrow function, so function statement requires a function name. I cannot do this like this. So same goes for your arrow function when you have something like this. So sorry, in arrow function, you can write it like this. My mistake. You cannot do it. So these are kind of two synonymous, but when you are passing this function in a callback method as an anon function or an anonymous function, as you saw, do I have that open, the code pen? Okay, I did not save it. Okay, it's fine. I did not save it. So when you saw that, I could have passed it out there. But even in that, if I have done it, I should have saved it. If I would not have used the bind out there, that function, if I would have passed an arrow function out there, that this would be global this. Let me take a moment to write it, because that's a good question. I think this thing should get clarified. It's a very good question. So let's take a moment and try this. And if we cannot finish it today, it's totally fine. We will probably follow up in some other day. But if there are any questions, we should clarify it. So we'll do all of them. So first we'll start with the basic one, which we had, which will be, so we know that this is going to print the button. So if I do click, so we know that it has printed the button. So let's do an arrow function right now. Then we'll go to the bind. See if I have an arrow function out here. Why is it throwing an error? There shouldn't be any error. This is fine. Either way, we'll see what is the error. Unexpected token. Interesting. Let me write it. This is fine. Where is the error happening? Okay, we'll just try it. You can see this one, right? This log was too large for our console. You need to use the browser console instead. So this is actually printing the global this. So this is the global this out here. This is the window. So arrow function is always scoped to the lexical this. This itself call for a different topic. We'll talk about this, but just to clarify. So whenever you're using arrow function, it will go to the scope, whatever the immediate scope of the execution. So arrow function has its own way. You doesn't always have to specify that this, it will take the this, whatever is available in the outer scope. But if you see the React example again, when we are showing it, in a class out there, you have to use the bind. So these are the two different things. But arrow function is not a alternative for bind. These are two separate things. Arrow function will have the local scope this, but in bind, you can have whatever you want, like anything which is not even belonging to that scope. But if you have access to an object, you can always pass it and you can do it. So these are the two different.
So to summarize this, so bind generally used to make the copy and make sure we are pointing the targeted object.
That's right. Bind is basically when you're running the bind. If you remember the bind syntax again, like if you see this guy, if you see the bind syntax when somebody is using, where is that? Where hasn't he?
Go back up.
No, this is the bind definition. I wanted to see where he has used it. So if you see here, the bind. So bind is so what it is doing, like he's calling a function. So this function will be returning a function. So this is creating a copy of the function with what you just said, with this pointing to the override which you have provided. You have summarized it correctly.
Oh, awesome. Thanks for the clarification.
No worries. So we actually, it is good that we had this discussion. We kind of covered few of the things which we are supposed to talk about in the next slide. So let's move forward with, but then again, please, if you are planning for front-end interview, please brush up your prototypal inheritance skill, because there will be some questions in one form or the other, which will be based on this JavaScript inheritance, because this is the fundamental of JavaScript. So please brush it up. So asynchronous execution. So we touched upon it a little bit last presentation, that JavaScript is a single-threaded model, and single-threaded paradigm. I shouldn't use the word model. So there is only one thread which is running, and whenever there is an interrupt, there is something happening. So it responds to those interrupts. So as you can see in this diagram, if I lost my cursor somewhere. Okay, if you can, I don't know where my cursor is, but then again, if you can see in this diagram, there is an application which is assigning many tasks, many callbacks to this event loop. It is basically telling you, hey, there is some sorts of registry. Hey, when you are done doing this thing, call me or call these functions. So everything is getting associated out here, and this single threaded, whenever it is getting these blocking operations, generally IO operations or network operations or similar kind of operations, it passes. Don't consider, by the way, don't consider these threads as the JavaScript threads. Those are not JavaScript threads. Those are the system threads which are working. So one thread could be talking to the printer. One thread could be talking to some disk management or something like that. So those are system threads, not JavaScript threads. So JavaScript will be setting up a process on the system front, and will be waiting whenever there is an interrupt which is happening, similar like Unix interrupt. So when the interrupt comes back, it has the registry. It will map that interrupt to the callback, whatever was there, and it will execute those callback accordingly. And this is the whole notion of asynchronous programming. Once again, JavaScript is nothing but functions. Everything is a function. The global thing is a function, and you wrap everything within a function. A function can accept a function as an argument. A function can pass a function as an argument. And this is the notion which we call as higher order function. So I think last year or sometimes I was a little bit curious how this terminology originated. So I did a little bit of research, and I wrote down my findings in this Medium post. And if you go there, you can find out that this is not a brand new concept. This concept already existed, and it traces its root back to 1891 by a German philosopher out here, Frege. He states about higher order function way back in 1891. So we take similar kind of concepts in JavaScript and we move forward. So everything is a higher order function. Every function is a higher order function. Function is a first class citizen in JavaScript. So you can pass a function to any other function. You can return a function from anywhere else. You could do anything with the function. You could even add attributes to function too. So one code time out here, it should be very, very straightforward. This is a separate REPL, which we see. So success is a function, failure is a function, process is a function. So I'm passing an argument called number to the process, and I'm also passing success and failure. So depending on the number, it will either call success or either call failure. So this is the very, very basic of callback pattern or asynchronous programming. So this is a very simple program, but still it establishes the concepts of what is a callback function, because in languages like Java and all, you might, I'm not sure Java has Lambda right now. I don't work with Java directly for a long time, but when I was working in Java, you could not pass functions like this. You had always to pass an object and you would call the function on an object. So if you run this program, let's comment out everything. And interesting, it did not save, it just refreshed it. Okay, fine. So if you run this program, you see nothing. What happened? Interesting. Why did not it print anything? Let's run it again. You know what happened?
I think we didn't call a process.
Absolutely. I just noticed it, and you also said the same thing. I have not, and the reason I did not call the process, because I wanted to show both the thing, and I completely forgot, because I wanted to show one with the even number and one with the odd number. By the way, if you think that, okay, this process's name has to be the same as how I have defined, no, they doesn't have to be. So let's make it S and let's make it F, so that we clearly understand that they are not the same thing. So the references are getting copied out here. So let's change it. So now if we run, we know that this is a even number, so it should print hooray. And if we had passed an odd number, it should print oh no. So, but the concept is established out here. I think this is, I'll take a pause here also, and I would really like to understand, did you get the notion out here that you can pass a function and it's just like that? And let's do.
Yes, absolutely, Sarvottam. And thank you for changing the name of the process parameters to S and F, because I was beginning to wonder the same thing. So thanks. Now this clarifies. Absolutely.
Now let's do a little bit. Let's take it a little more. Let's return a function from this function. So right now, as I told you in the very beginning, if a function is not returning any value, it is returning undefined. So if we had to do a console log here also, let's do it console log. You will see it will print undefined as expected. No surprises out here. So let's return a function from here, because we are not. So if I have to return, just for the sake of completion, let's just return 2. We just know that, okay, it is printing the return variable. It was undefined. So let's return a function, and that's, we are establishing the notion of higher order function, and that is the base of asynchronous programming. And I'm not sure, I could not see your name, but somebody asked a question. You could actually return a arrow function from here also, no problem. So let's return a function which will print console.log I have been returned. So now let's run this function again. So now we see, oh, okay, the return value is a function. So what can I do with that? So let's get rid of the console log. We don't care about the console log because we are trying to establish it. Now I can actually execute this function. So I call this function process, it returned me a function, and I will now run this. So we see that it executed, it printed, oh no, we got a function back, and we can execute that. And the opportunities are infinite, but you probably don't want to go down the rabbit hole. You want to stop somewhere. You don't want to keep on passing functions, and you don't want to change so much. Chaining is actually helpful, but just don't go crazy with that. Like, keep it to a certain limit. You really don't want to go that far. So now we know what functions are. So why do we care so much about what was my index? Let me just take a look at it. Oh, we should also talk, we should probably finish this part. Let's talk about different callback methods. So we understand that this is a callback mechanism, and let's see some in the which are already available in the JavaScript. So we'll take a look at the callback functions. These are already available in the JavaScript. So you probably, if you're writing JavaScript, you must have seen this for each syntax. And this for each, so this is an arrow function, by the way. I don't really care about this out here, since I'm just working on this collection. And if I had to, I probably would do differently, but I don't care right now. So I'm also passing a function. Though I written it as an arrow function, it could have been written as function. This would have been my parameter, and I will get rid of my arrow, and it will just work fine. So this is a notion of callback pattern. We have the same in when we are using array methods like filter, map, reduce, sum, and so on and so forth. You can probably write your own also. Just have a function. So this function for each is available. So I have a quiz out here. Okay, I'll take a pause. It's totally fine. Feel free to give a wrong answer also. Where do you think this for each method is defined?
So might be in the prototype of the array.
You are right. Which array? Fruits array or where?
No, it's the global array, which is defined in JavaScript language.
Got it. Okay, that means That means at least you understood what prototype inheritance is. Whatever I have been doing the speaking, thank you for answering
Yeah,
this.
it
Yes.
was completely a clear explanation, and really appreciate it. It was so clear today.
Yes, for each is defined in the prototype. So you can define some more methods out here if you have to do it, because a filter, sum, reduce, map, they weren't there. If you heard about a library called Lodash, the Lodash actually got all these utility method, and then it got accepted. It became mainstream, and it actually came to the JavaScript engine. So it wasn't there. So this is a very, very basic example of callback mechanism, that you are calling this function for each, passing a function and telling it what needs to be done. So it's kind of a similar to, not exactly, but similar to kind of a command pattern. You are passing the command, hey, do this thing. You don't do anything. You iterate over this collection. You give me this basic, these parameters to my function. I will do whatever needs to be done. You just call this function. So that's how, that's the notion of callback pattern. So let's see another one. So this time we will be reading a file and we'll be printing its output. And this is the reason why we probably needed REPL. We can do it on the browser, or you probably have to have a editor setup. So I have a file here, a text file, which has some text, and we will be reading it and we will be printing the output. So just like previous notions. Oh, I did not even run this. So just run it. Let's run the array method real quick so that we know what is happening. So we know that it has, if we see the question again, we had apple, banana, orange, pears, some fruits, and it just iterated over that collection and it just printed. And you might have also noticed that it maintains the order. So when you are iterating over an array, all this method will maintain an order. So let's read a file and write it. So let's run the program even before you see it, then we'll get to the program. Okay, so I see we wrote something. What are these hello and everything coming? Okay, let's see the code. Interesting. I have the hello at line number 10, but the hello got printed before everything. So of course, these are the things which is telling, okay, which file I'm running, but hello got printed first and then this file. Why is this happening? Again, this is a question time, because let's make it a little bit interactive.
I think because of JavaScript is synchronous by nature, and this is an asynchronous read file where a file system has a read file method in Node.js defined. So since JavaScript is asynchronous, so it will print hello first. Then after it processes the data into streams, and yeah, it writes the file again.
You are right. Again, you are right. So what is happening? I'll just go through this code one line at a time. I'm getting a handle of the file system from the Node.js, and I'm calling a method read file on that file system, passing it a file handler, the file name, and I'm also telling what is the encoding, how it should read the file. And I'm telling that method, hey, once you are done reading the file, call this function, all arrow functions, by the way, because we don't really care much about other implications out here. Call these functions, and I as the consumer of, I as the invocator of this method, I will decide what I have to do. You don't do anything. So what JavaScript does, it sees this thing and it calls a file, a read file, which will make an IO operation. And let me go back to the slide a little bit so that we can see what is happening. So this is what is happening. If you see, maybe this is the task 1, or let's take task 2, which is actually also shows a completion. So JavaScript initiates the task 2 and resumes its execution. So when it is resuming into execution, it is executing. I have to click these things to go back to my editor, otherwise I can. So JavaScript has scheduled this thing, and it did not stop out here. As you have heard, like it will go back to the next statement or whatever statement out here, and it will keep on executing. So this console log is not even ready by the time this console log has reached, because this will, who knows, this could be a really, really large file. This could be 100 MB file. So it will come, once it will be read completely, then it will be available, and that's how it will be done. So JavaScript executed this line first, hello from the file reader, Ignore this one. This is just by the Node.js REPL. This is not anything to do with our code. And then when it got the data back from file, it started writing it. It started logging it. Let's take another example. So this is called set timeout. And as you can see that I have passed out here 0. So set timeout 0 means I'm telling, hey, take this whenever you are free, whenever, don't worry, run this thing. If I would have done it like set timeout 1000, 10,000, 1000, hey, take this and put a pointer after 1000 millisecond, that is 1 second, whenever you are free, run this. There is no guarantee that it will run exactly after 1000 milliseconds or 1 second. But there is a guarantee it will never run before 1000 millisecond. So if the JavaScript is already working on something, maybe a long running process, this set timeout will have to hold on to that one because the main thread will not be empty. So whenever the main thread is empty and this tick has happened, that is 1000 millisecond, this function will get executed. So let's run even this one.
Hey, Sarbotam, this is Suva. Can you go back to that code 1 second?
Which ones? Read file?
The 1000 millisecond example that you
Yes,
showed.
I'm going there.
Okay, and this is just reiteration for the folks on the call, right? So it's not 1000 milliseconds from the time it encounters that code. It is from the time the thread is empty, which means it is 1000 milliseconds after it prints hello, correct?
No, yes, you're right, but a little bit difference. It has, the moment it encounters this 1000, it has scheduled a timer that, hey, anytime after 1000 milliseconds from now. So let's imagine that, let's consider this is, let's consider the current time is 5:43, 1 second. So it is telling after 5:43, 2 seconds, whenever you are free, run this command.
Yes.
So it is not like when the JavaScript is free, 1 second after that, the 1 second duration has already started. But if you cannot get a free slot, you stick around there. Whenever you are free, run it, but never run it before this time.
Yes. Got that part, yeah.
So now if we run it, once again, no surprises, you will see this hello first, and then you will see this hello after 1 second. So please pay attention to this console out here. You will see that you will not see it immediately, but it will take some time. Okay, let me clear it up. It did not clear the whole thing. Oh, is it running both the things? No, it should run only this thing. So see, the hello got printed, and after 1 second, you saw that hello from timeout. If I had many more things, if I had a long running program, it will just get delayed. So this is another way where you would use callback. But the last but not the least for today's session, you have already seen this callback, that when you have any kind of button or any kind of thing, you have an event which is getting emitted, you can also associate a callback with there. So you already saw this syntax called add event listener.
Hello. Can you go back to the previous example and set the timeout to 0 seconds? Let's see.
It will still run after this hello.
Yeah. Oh, okay.
So I think, let me reiterate on your question. Whenever you are giving a set timeout, it really doesn't matter whatever it is. It is not going to block the main thread's execution, whatever you have. So let me put, just for the sake of this, I'm putting something random, and it's a time consuming thing for the browser, for the Node.js engine to print so many hellos out there. See what happens. No matter how many things you are executing, the set timeout will only get executed when your main thread is free.
Okay.
Yeah, seems like this is how event loop works under the hood in JavaScript, right?
Yes, this is how the event loop works under the hood of. So event is a loop which is going through that, and you have a queue which is a FIFO queue, first in, first out. So if I had, we can actually extend this a little. Let's see something really interesting. So let's put this back to 1000. Okay, so this is timeout 1000, and we'll put timeout 0. So now see what happens if we run this. So first, since this is 0, this will be immediate whenever it is free. So first this hello will get executed, then timeout 0, then 1000. So let's run it. I hope now it might be clear how set timeout is working. Any questions?
Yeah,
no,
I think it's clear now.
Okay, fine. That sounds great. So let's move on to this event emitter, the callback event emitter. You kind of saw this one when I was doing the code pen exercises, like you had a button, you click on it and something has happened. So consider this is pretty similar to the same thing. So when I had the add event listener out there, consider it as the on. So I have an event handler associated out here, and I also have a arrow function associated. It really doesn't matter, both of them. So, and then I'm emitting the event. So suppose let's go a little bit maybe further. Let's see. First, let's run this. Then we'll go a little bit further. So let's change this. So the same thing will happen when we are in the event listener. So we will see a hello from event handler function. We'll see a hello from arrow function. And you should see it in the actual order the way you have registered. So now let's see something, what happens. We can wrap this whole thing. We can wrap this whole thing in a set timeout just to emulate that the user is clicking after 1 second or not. The same thing will happen because the event hasn't been emitted. Event emitted, and both of them is happening in the order the way it is supposed to happen. So we will see another example of a code pen, which we have out here. I'll open this up. So the main reason, so we have talked about callback, but why do we care about asynchronous execution? And this is the main thing why we care about. So this is the problem. So once again, JavaScript is a single threaded thing. And if you're doing something really, really long, the whole thread will be blocked and your UI will be frozen. If you're doing an UI work, your UI will be frozen. User will not be able to carry out any sorts of execution because nothing is going to happen. UI is unresponsive. Or if you are running a server-side code or a Node.js program, it will just be like taking a long, long time because you're just unnecessarily getting blocked when you can perform it asynchronously. Your time will get reduced further. So to emulate this, let's see what I have. I have, this doesn't even make sense, hello world, but I have two buttons, button 1 and button 2. I have a function called greet, and I have taken a handle of button 1. I have associated the greet function to click of button 1. Then I have a function called sleep, which is taking some arbitrary delay. But please make a note out here, never do this thing. This will block your main thread. Never ever do this thing. This is just for the demo purpose. Don't do this. It will arbitrarily block the main thread and then it will print hello world. So both are printing hello world or what? Let's change it to something hello hi world so that we know it is different. And then I have assigned this a long running function to the on click of this button 2. So if I click me, you immediately see hello world. If I click me too, you don't see anything. Okay, I don't know what is happening. I'm literally clicking. If you can hear me, oh, I see hello world after a long time. So I did not save this. Okay, CodePen has gone a little bit crazy. Let me save this and we will do it again. So let's save this. Oh, okay, that's what has happened. Okay, we'll reload it. I'll keep it as is so you will understand, otherwise I have to save it. So nothing happens and I click it 1. So let me save this as an anonymous. It will be fun. So it will not let me save it right now. That's the wrong thing. Okay, whatever it was, let's reload. I had sleep off. 5 seconds is good enough. So just watch carefully. I'm clicking click me too, and then I'm clicking. What happened? Something is there an error? There seems to be an error. Oh, okay. Sorry. I have to find other way to run this because it is taking so much of time. So it probably gone into an infinite loop. It has blocked it. Let's see. So let's see. I think we didn't get any error. Let's see what happens. So I clicked the first one and the second one. So you see an hello world, it probably gone and again out there. Some sorts of loop has happened. Okay. I'm sorry, it's something gone wrong. This is not working. But technically speaking, if you have a long running program, it will just block everything. My other execution will not happen. I'll see at the end of the session if I can recreate this problem again. But it unfortunately didn't happen. So this is why we need an asynchronous execution. We just don't want to block it, because if you have asked me to write a paragraph, you just don't want to sit out there and wait for me as I'm writing the paragraph. You will probably go and do something else, and you will tell me, hey, when you are done writing your paragraph, just let me know, because that is much more time efficient. And this is not a new concept. We are in our everyday life, we generally do this thing. Email is the best example of asynchronous communication. I send an email to somebody. I'm not just waiting out there when that person will get back to me. They will get back to me when they're done. So it saves time. And in the meanwhile, I can do something else. So there are many ways like we could do these things. Like I could, like probably, like you have asked me to draw a picture, and maybe you want somebody else to paint that, or maybe let's take it like that. So first you have to tell me that, hey, draw this picture. Then I'll tell you, hey, the picture is done. So when I tell you the picture is done, then you're probably going to tell somebody else, hey, paint this picture. And that person, when they are done painting that picture, maybe then you will tell somebody else, hey, frame this picture. So you can see like this is already becoming one after the other, one after the other. And the way we generally write this code, it becomes really difficult to read. It's over the time, it becomes really difficult. So let's see an example of nested callback. So what I'm doing out here, this is not a big file. This will be a small file. All I'm doing, I'll be reading a file, which is this another text file. As you can see, I have similar things, but there is a typo. Like wherever I had to print A, I have printed I for whatever reason. And I know maybe the keyboard was not working. And I know this is a consistent problem which is there in the file. So I would probably like to update them and print it properly. So what I did, the same thing you already saw me doing, reading a file. I'm reading a file, and when the callback is getting passed, I'm validating if there is a data. If there is a data, I'm replacing all the I blindly, all the I. This is a regular expression, by the way. When you give the flag G, that means all occurrences. So I'm replacing all occurrences with A. You probably don't want to have such a bad regular expression. This is a really bad expression. This is going to probably ruin more than doing some benefit to it. And then I'm writing it to a file, that another text file corrected nested callback. And if there are, and I'm passing another callback function. If there are no error, then I am printing, this will be printed at last. Now, if you look at this callback, the console.log statement, you already see that it is getting nested, and it is getting kind of a reverse, kind of a pyramid structure, which is increasing in the horizontal flow. And it is not very easy to put it cognitively, right? Because this guy will get printed first, this guy will be printed next, and this guy will get printed. If you are, as a human, the way we scan things generally from a very specific way, how we have learned to scan things, either in one direction. Even if you're reading a language which is RTL, it's a consistent direction how you read, whether it is RTL, LTR or anything, even if it is a Japanese, if you are reading it in a consistent pattern vertically. But if you see this one, like it's constantly jumping the context, and it is not very easy to grasp it. Even if you're maintaining the code, it's pretty difficult. But then again, it works. So let's run this and we can see it. So if you have noticed, like it already, this file did not existed. It created this file, another text file corrected nested callback. And now it has corrected everything. My file, it was wrong, like orange or something was there. Now it is printing correctly orange, apple, banana, pears, and cherry. And if you see on the right side, the console log statements are getting printed, like this will be printed at first. The program execution is over. That's why you see this 2 parentheses from REPL. This is happening when file read has happened. And this is happening at the last when the file write has happened. So by the way, just a quick time check, it is 5:57 and we have 2 more programs left. So I'll really appreciate if you can stick around, and if you have any questions. I know we might go a little bit over the time, but I wanted to be slow so that you understand the gist of it. It's a no good if we just hurry and finish everything and we'll not understand. So let's see. So we know that this is difficult to read, right? Because it is not sequential. So what JavaScript did, so there is a notion called callback hell. You can search in the net callback hell and you will see how deep this can go, and this can create a lot of problem. So JavaScript came up with something called promises. So it is not an exact better replacement, but still to somewhat better. So what we are doing in this exercise, we are taking the FS promises instead of just taking the FS file system. In the previously, we are just using FS directly. Here we are using the promised version of the file system, and we create a promise called read file. So promise is something like just how you make a promise. Hey, I will do this thing for you. So whenever you create a promise, it returns you with 2 methods. One is then, one is catch, and you then call sorry, it's a Freudian slip. So in the then method, you can pass a callback function, and which will then get executed. And similarly, if there was an error, you can pass a catch function, and so on and so forth. We will not go in exact details of the promises right now, because there are better things which we'll see. So you have a read promise, which you are telling, hey, read this file. Then to the read promise, then you are creating a write promise, which is nothing but when the read promise will be over, then you are telling the read promises then, hey, you know what? You do this thing and return me another promise, which is like replace all these occurrences of I with A and return me this promise. This is exactly the important thing. You might not have seen this in the previous exercises. When we are doing nested callbacks, we literally did not care about what is returning. But when you are working with promise, this then function should also return a promise, because I am looking for a promise. So this guy will return this promise. This is really important, but it can be confusing. If it is sounding confusing, don't worry too much. Just go with the flow, because things will get simpler in the very next program. So now this guy itself is a promise. So as you saw, you had a then function on read file promise. So you should also have a then function on write file promise, which is exactly out here. And this guy is doing, this will be printed at the last. So this is not the very good flow. Still, this guy is getting printed first, but the next of the things are at least maintaining some sequence. So you have the next, and then you have the last. So other than the first one, rest will follow some sequence. So let's run this, and you will see we'll have a file created, another file corrected, promise. So let's run this. We are already in that. So we will see another file got created out here, just like the previous one. And at least you see that this is first, second, and last, the way it is happening. At least the next and the last was in some sequence. So file got created exactly how we expected it. Last but not the least is async wait. And I think this is the best one. But in order to have an async wait usable, you have to wrap it in a function, because everything in JavaScript is function scope. And this function, though this is an arrow function out here, it could have been a other anon function, but I really don't care about this or any other context out here. So I just used anon function, and I have prefixed it with an async keyword. So this is something new. And if you saw the function properly, that I'm wrapping this whole function out here, and then I'm executing, because this function needs to be executed. I could have done something like this. I could have done some file async, and I do not have to run this. I could have done something like this, and something like this, and then I could have executed my file async. But this is just like, it's up to you. How do you prefer? But it is totally fine when you have this kind of function. And this syntax in JavaScript, it's there in maybe other languages, I believe, like Scheme or Smalltalk. I'm exactly not sure how many languages has it, but this is called IIFE. So 1 second, just bear with me for a second. So this is called IIFE. It stands for immediately invoked function expression. IIFE. I'll just write it here. So this is another thing, IIFE. You might want to take a look at it. You'll probably find some Wikipedia article, but the all gist of it, like you write a function and immediately execute it. So this is called IIFE. Now, if you see this function, we probably don't need this thing. This is completely sequential. All you are doing, this will get printed first. Okay, this is coming at first. Then you are telling let data. So you're using this keyword called await. And if you see, we are still using promises, but we are prefixing the promise with wait. What happens when JavaScript engine sees this execution, the await, it knows that, okay, I have to wait for a promise to be fulfilled. So promise has to be either resolved or rejected. So promise needs to be fulfilled. What it will do, it will block the execution of this code. So the way it is happening, this is not happening in the main thread. That's why you have to always wrap await execution in a function. So this happens, JavaScript will create some sorts of notion in its event loop that, hey, when these promises get fulfilled, assign it to data, then execute this thing and keep on executing unless and until you are blocked. Then it replaces the data. Then again, it executes, it encounters with another await. And here it says that it is writing to a file. So it will again pause out there till this promise is fulfilled. Once the promise is fulfilled, I have not assigned its value to anything. I wanted to keep it simple, but you want to assign its value to something. The promise might give you something back out here. You could suppose if there was an error in writing the file for whatever reason, disk space has run out or something. So this is also a good practice. You would like to wrap your await executions in try catch. I have not done it, but you would like to do it. So you'll have the error out here, and if anything has gone wrong, it will throw you the error. Otherwise, you will have access to whatever the output of that promise is supposed to give. So this code looks much more, at least to me, I can reason with it. Whenever I can see any code, I do not have to do that mental modeling in my mind. Which one is getting called first? Which one is getting called second? And if we run this, so again, without any surprises, we will see that this is so well related to our cognitive ability. At least I find it so, like it is much more easier for me to read. So exactly the mapping, this statement is coming first, so it gets printed first. Again, these are promises, so these are getting printed asynchronously. REPL has completed. You see the next statement at next, and you see the last statement at the last. So I think this is the best way today. But here is the catch. Like if you are running code for browsers, and if you're writing code for older browsers, they still do not have support for this. So you have to add a polyfill, and this polyfill is a big chunk of polyfill, so which is going to increase your payload size. But if you are writing server-side code, your Node.js code, there should not be any excuse for not using promises, the async and wait. you should definitely use it. So that was the last thing that I want to talk about. And all the code examples that you have seen are available in these slides. I'll be sharing the PDF version after a while. And once again, for resources, you should definitely check out Asynchronous JavaScript and MDN article. And by the way, I didn't even realize that, okay, there will be an article with the same name, how I named my slides. But I think that is the beauty of JavaScript. You have very limited terminologies and you use the similar notion. So check out this Asynchronous JavaScript in MDN documentation. And Jake Archibald has a very well-written blog post about the whole event loop, how tasks are happening, how micro tasks are happening, what are queues, what are schedules. And now it gets, he gets into much more granular detail. Like if you have a promise and if you have a set timeout, there is a precedence. The promise is a micro task, so it might get precedence fast prior to the set timeout. So definitely check these things out. And if you want to pursue your career in front-end engineering or in JavaScript world, even if not front-end, but server-side JavaScript, the two topics which we have discussed, they are extremely important. So maybe these slides can help you as a ready reference, but do brush up these documentations and these resources. And that's all. And thank you everyone once again for your time. We ran a little ahead of time. And thank you BayOne, Subha, and everybody from BayOne for setting up these sessions. We had a lot of questions during the interactions, but if you have any more, I'm more than happy to try to answer them. Thank you again.
Thank you, Sarvottam. So if you happen to look at, you can stop sharing now, and you can, if you see the chat, it's just a reiteration of the event loop, so regarding the callback queue, there's a comment from Dheeraj. I don't know if Dheeraj is still on the call, but you may just want to read that and reconfirm, Sarvottam.
Yeah, actually, I'm still on call. So yeah, just need a clarification on that. So is my interpretation correct? So
I'm checking it out. I did not check it, but thank you, Dheeraj, for sending. Seems like event loop has one simple job to monitor the call stack and callback queue. If the call stack is empty, it will take the event set timeout from the queue and push it to the call stack, which runs. You are correct. You are. This will be, if I have to superficially say it, but the moment you see the event loop, it is not just a single thing. There are many layers to it. So when you start reading the document, you will see the different out there. There are different kind of queues out there. There is something called ticker queue. There is something called poll queue. So which are further granular breakup of these things. But what you suggested, yes, superficially, that is the exact correct thing. Whenever your main thread is empty, it will just take one from the queue and put it in the call stack and it will just execute.
awesome.
Your interpretation is correct. But but when you want to dig deeper, please dig deeper, because there will be separation of queues out there and different queues have different priorities.
Got it. Yeah. Thanks, Sarvottam.
So thank you, Sarvottam, for your time today. There are a couple of follow-up questions we got via email, so I'll send them to you separately. We might potentially need another session. But again, from all of us here at BayOne and all our participants today, Sarvottam, thank you very much. We truly appreciate your attendance and we truly appreciate your teaching us such an interesting topic today.
My pleasure. I hope this was useful, and feel free to reach me if I can provide any clarifications. But please read the documentation which I shared in the resources. This will be very, very helpful for you. Once again, thank you all.
Thank you, Sarvottam, and thank you all. Yeah.
I think I have to make you the guest, Subha, or you will it. Okay, I'll just leave.